We'll now review NX assemblies. In this particular data set, we have several components. Assembly constraints have already been added within this assembly to constrain some of the components. And we see that there are many different types of components, and we see that constraints are added accordingly. We want to uncheck one of them, and then today we'll review some of those functionality within the NX assemblies. And let's go ahead and take a look at one of the assembly constraints. So in the constraints, when we uncheck one of the constraints, we see that we have ability to move components, and this is the end result of our proper assembly constraints. So we'll now proceed how to do that.
Now we're ready to add our first component. We'll go to File New, and in the File New that we can see a directory or a folder where we want to add this particular component, where it comes from. And then we also want to select a name. In this case, we see that we have a variety of different components or exists in that folder. In this case, we want to select that piston assembly as one of our destination name for our assembly. We're going to type in _ASSY. NX is one of the CAD systems that does not distinguish between part or assembly or drawing file name. So a lot of time that user just create these additional annotation to distinguish the file type. NX only have one file type, is .prt. So once that is done, the add component option remains. So in this case, as we select the location, and then we see that wherever our cursor stops, that's where the piston will come to a rest. So in this case, we want to change that to an absolute location, and then we can expand by the placement and adding a constraint to this. So this one, we see that this piston is going to be the primary of at the beginning of all of our other components. We will really want to add a fixed constraint. This fixed constraint, as we go into Assembly Navigator, expand that, we see that the piston head is in the fixed position. Now we're ready to add other components. All right, we're ready to add another component to this assembly. So we're going to select Add Component. So once we select that, the user interface gives us the option to select the connecting rod is what we're interested to add to this subassembly. So once we have that done, current assembly location is set to snap. So as we move the cursor, we can place it at any orientation that we want. If we don't like it, we can move it by selecting the move and drag onto the handle. We can drag onto every one of those handles and then place it to a little more orientation that we desired. Then we want to select the constraint option again. We want to select 2 to 2. That means from the component, we're going to select 2 faces, and then as we target where we're going to constrain the 2, we'll have 2 faces to select. So quickly, NX will orient the geometry, and then you can drag onto the front geometry by just using mouse button 1. Now by doing so, because of our piston is in a fixed position, so others will not move. Now we're ready to select the align. So in this case, we want to make sure that instead of selecting faces, we want to select the center axis. We want the axis to align with one another. So the touch and align is very critical that we select a proper. So now once again, we can see that as we drag onto the connecting rod, it moves accordingly. So we know we have created the correct assembly constraint. All right, as we have done so far, we want to quickly review what kind of assembly constraints that we have already added to this assembly. We see we have fixed, center, and line. We can also review this results in the Assembly Constraint Navigator itself. We see that we have both of those are partially constrained. That means they're not fully constrained. That means the connecting rod can kind of swing in the context of the piston at this time. Let's ready to add another component. So in this case, we want to add the bearing cap. The bearing cap goes on the bottom half of the connecting rod. So as we select a location of where we want to place this, once we snap it to a kind of a screen position, we're ready to add assembly constraint to this bearing cap. So now we want to use the concentric. What concentric does is that it will do assembly mate and also align all in one shot. So we want to select the two, basically the face edges. So we see that as we move around, see that it still has that degree of freedom to move. Then we want to select the outer edge of each one of those. And then as we select that, as we zoom in, we want to make sure we select to the proper one. So now that is properly constrained. All right, now we're ready to add our final component. So in this case, we can see that we have some assembly constraint display that on the screen of NX session. We can turn that on, turn that off using the right mouse button under the constraints. Let's go ahead and add the last one. In this case, we want to add a wrist pin. The wrist pin is going to automatically come into the position just because the current WCS orientation matched the wrist pin location. So let's go ahead and snap that to an outside location. And the first thing we want to do is just create a line. We want to line the center axis of that. As we see that we can drag that out because it still has degrees of freedom to move. So we want to go ahead and just create a 2 to 2 of the center from the pin, the wrist pin, to any of these geometry. In this case, we want to grab onto the connecting rod. So that of itself, just quickly align that. And once that is done, we have all the constraints added. We can turn off the constraint indicator on the graphics window. And then we see that we still have partially constraint, which is the connecting rod. So that means that it can move, and then all the components are aligned to it will move with it. So in this case, we want to make sure to drag onto the connecting rod. So we see that that is moving, so we know that it is behaving like it should sit inside the engine. This concludes our demonstration of assembly constraints.